This is a GMAT data sufficiency hard math question. I'll classify this one as a 700 to 750 level question. This is from coordinate geometry. Core concepts tested, basically equations of straight line, distance between 2 points whose coordinates are given, and one other important concept, which is the perpendicular distance between a point and a straight line. Does a line x plus y equals 6 intersect or touch the circle whose radius is 5 units? As always, we have two statements in any DS question. But before we look into the statements, let's do two things. One, let's get clarity on when the data is sufficient, the usual stuff that we do with any DS question. The second one, which is very important as far as this question goes, is consolidating and getting key concepts in place that are required to solve this question. Let's start with the first one. This question starts with a be verb does. So if it's a question that starts with a be verb, which is very similar to a question starting with is, the answer to such a question is going to be an yes or a no. When is the data sufficient? If we get a definite yes or a definite no as the answer, the data is sufficient. If we get a definite no, note this, even then the data is sufficient. So many times we fall into the trap saying that when you get a definite no, we'll think that the answer is not sufficient. The answer is definitely sufficient. We'll invest a bit of time into the second part, consolidating key concepts required to answer this question. What is this question wanting us to determine? The question wants us to determine whether this line x plus y equals 6 intersects or touches the circle whose radius is 5. But the only information we have about the circle is that its radius is 5. Now, let's pick some circle. We do not know where its center is. This is the center of the circle. Radius is equal to 5 units. So, the distance between the center of the circle and any point on the circumference of the circle is 5 units. That's what the definition of radius is all about. If our line x plus y equals 6 intersects with this circle, this is possibly the case. Conversely, if our line touches the circle, this is going to be the case. It's going to be touching it at one point. If it is going to intersect, it's going to pass through the circle and will touch it at 2 points. So these are the two scenarios we have. When is this going to happen? The line will intersect or touch the circle if the shortest distance between the center of the circle and the line is less than or equal to 5 units, which is the radius of the circle. If it is less than 5 units, this line is going to have a point inside the circle, which means that it's going to intersect the circle. If the shortest distance is exactly equal to 5 units, then this line is going to lie on the circumference of the circle, which means it's going to be tangential and it is going to touch the circle. Conversely, if it is not the case, if the shortest distance between the center of the circle and a point on the line is greater than 5 units, then this line is going to be somewhere here. This distance is greater than 5 units, and which essentially means that it is not going to either touch or intersect the circle. So we know when the answer is yes, and we know when the answer is no. Now let's get some idea about this equation. X plus y equals 6. What kind of line is it? Positive sloping, negative sloping line? Rewrite this equation to mimic the y is equal to mx plus c format. So what will we get if we write it as a y is equal to mx plus c? We're going to get the equation of the line as y equals minus x plus 6. So the slope of the line is equal to minus 1. It's a negative sloping line. Substitute x is equal to 0. Then we'll get y equals 6. That's a y-intercept of the line. Substitute y is equal to 0. We'll get x is equal to 6. So 6 is the x-intercept of the line. Y-intercept is 0, 6. X-intercept is 6, 0. Join these 2 points. We know what line we are talking about. So this is our x plus y is equal to 6 line. It passes through the second quadrant, the fourth quadrant, and passes through the first quadrant. So all of this information we have about this line. Let's get a couple of formulae in place and one key idea in place, and then start evaluating the statements given to us. The first one is basically the formula to compute the distance between 2 points whose coordinates are known to us. The coordinates of the 2 points are x1, y1, x2, y2. Then the distance between the 2 points is given by under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is a formula that all of us know. The perpendicular distance between a point x1, y1. Let's say I have a point whose coordinates are x1, y1. The perpendicular distance between this point and the line given, that is given by this particular formula. The equation of the line is ax plus by plus c equals 0. So we'll have to rewrite this equation as an x plus y minus 6 is equal to 0. It should resemble this ax plus by plus c equals 0. The coordinates of the point are x1, y1. Then the perpendicular distance between the point P and this line is given by modulus of ax1 plus by1 plus c divided by square root of a square plus b square. A and b are the coefficients of x and y in the equation. And basically x1 and y1 are basically the coordinates of this point. For instance, let's take this equation x plus y minus 6 equals 0, and I want to find out the distance between, the perpendicular distance between the origin 0, 0 and this line. How do I go about it? Basically plug it in here, ax1. So 1 into x1 is a 0, so this becomes 0. 0 plus 0 minus 6 divided by square root of a is equal to 1, b is equal to 1. So 1 square plus 1 square. So the distance between the origin and this line, the perpendicular distance between the origin and this line is equal to modulus of minus 6 will be a 6 upon root 2. Lastly, this is very important. The shortest distance between a point and a line is a perpendicular distance. Here we talked about the shortest distance. That shortest distance between any point and a straight line is always the perpendicular distance between the point and that straight line. Let's start evaluating statement 1. Statement 1 tells us that the center of the circle lies in the third quadrant. Third quadrant is a quadrant where both the x and y coordinates are going to be negative for any point in that quadrant. Question stem, only information we have about the circle is that its radius is 5. Equation of the line is x plus y is equal to 6. What's the approach I'm going to take to look at this particular statement? I'm going to look for a counterexample. If we have a counterexample, if we have one case where the point lies, the line lies within the circle, and in one case where it does not lie, then we'll say that, hey, both possibilities exist. Knowing that the center of the circle lies in the third quadrant is not going to help us answer the question. That's the approach I'm going to take. Let's get started. This is a line we know, which passes through 0, 6, 6, 0, second quadrant, first quadrant, and the third quadrant. The center of the circle lies in the third quadrant. I'm going to pick some distant point, minus 10, minus 10. This is the center of the circle. I'll represent it by C. Let's find out the shortest distance between the center of the circle and this line. If that number is greater than 5, then we'll say that no point on this line is lying inside the circle. Right? Radius of the circle is 5. Let's compute the distance between x plus y minus 6 equals 0 and minus 10, minus 10. That's given by this formula. So minus x1, which is minus 10, plus y1, which is again a minus 10, plus c, which is equal to minus 6, divided by square root of a square plus b square, which is 1 square plus 1 square. I'm essentially plugging in the value of x1 and y1 as minus 10 and minus 10 in the formula that we saw in the previous slide. So this value works out to minus 26, modulus of minus 26 divided by root 2, which is equal to 26 upon root 2. 26 by 2 is a 13. Root 2 is definitely a number less than 2, which means that this value is greater than 13. Our important thing is 26 by root 2 greater than 5? Yes, it's certainly greater than 5. So if the distance between the center of the circle and the line, the shortest distance, which is a perpendicular distance between the center of the circle and this line, is greater than 5, then no point on this line is lying inside the circle or on the circumference of the circle, which means that this line neither does it cut through the circle or intersect the circle, nor does it touch the circle at any point. Answer to the question is a no. The counterexample, all that we know that is the center of the circle is in the third quadrant. We know the line passes here, which is not anywhere in the third quadrant. So let's pick a point really close to the origin, which is in the third quadrant. The center of the circle, let's take that point to be a minus 0.1, minus 0.1. Let's check out what happens to the perpendicular distance right now. The perpendicular distance, we're going to run through the same formula, except that instead of x1, y1 being minus 10 and minus 10, is going to be minus 0.1 and minus 0.1. So between C and this line, the perpendicular distance is given by line and this point C. The perpendicular distance is minus 0.1, minus 0.1, minus 6 divided by square root of 1 square plus 1 square. So this is equal to modulus of minus 6.2 divided by root 2. This is equal to 6.2 divided by root 2. Having a sense of number really helps us figure out whether this number is going to be greater than 5 or not. Root 2 is approximately equal to 1.4, 1.4142. So this number is greater than 1.4. I am basically truncating it at 1.4. 7 by 1.4 is equal to a 5, which means 6.2 divided by 1.4. This number is going to be less than 5. So if this number is less than 5, this is the perpendicular distance between C and this line, which means that this point, whichever is the point where it meets this line, is going to be a point which is going to lie inside the circle because this distance is less than 5. If a point on the line is lying inside the circle, then essentially this line is going to cut through the circle, is going to intersect the circle at 2 points. So knowing that the center of the circle lies in the third quadrant is not helping us determine whether this line touches or intersects the circle or otherwise. So statement 1 is not sufficient. Let's quickly summarize it in a printed form. I'm going to take it a little different approach. Just in case you did not want to use the perpendicular distance formula, I'm going to consider a point on the line. 3, 3 satisfies this equation. So 3, 3 is a point on the line. That's very sure. I'm going to pick the center of the circle to be something. There I took a minus 0.1 and a minus 0.1. I'm taking a minus 0.5 and a minus 0.5. It lies in the third quadrant. I'm going to check the distance between these two using the distance formula right now. It's an alternative approach to figuring out whether there's a point lying inside the circle. This distance is going to be equal to 3 minus of minus 0.5, which essentially will work out to 3.5 the whole square. Same 3.5 the whole square. 3.5 square is a 12.25. 12.25 plus 12.25 is 24.5. Square root of 24.5 is less than square root of 25. Square root of 25 is a 5. So this number is less than 5, which means that 3, 3, if the center of the circle is at minus 0.5, minus 0.5, is going to be at a distance which is less than the radius of the circle. Which means if the center of the circle is minus 0.5, minus 0.5, there is a point on the line that's lying inside the circle, which means this line will intersect the circle. So I didn't use the perpendicular distance formula. I've used a different formula. This is another way to approach it. If this be the case, if this is the center of the circle, then the answer to the question is an yes. The counter example, we'll have to look for some case where it is going to be a no. Let's pick something really far apart. We've taken the minus 10, minus 10. The perpendicular distance between minus, minus 10 and this line x plus y minus 6 equals 0 is a 26 upon root 2, which is greater than 5. If the perpendicular distance, which is the shortest distance itself, is greater than 5, then any other point on the line from minus 10, minus 10 will be at a distance which is definitely going to be greater than 5, which means that no point on this line is going to lie within the circle. The answer to the question, if the center is at minus 10, minus 10, is a no. So we get sometimes yes, sometimes no. Statement 1 is not sufficient. Eliminate answer options A and D. We are down to B, C or E. Let's evaluate statement 2 alone. The approach I'm going to take is one of counter example for this statement 2. It says point minus 4, minus 4 does not lie inside the circle. Just sometimes when you read the question quickly, we'll think that the center of the circle is at minus 4, minus 4. No, there is a point minus 4, minus 4 that does not lie inside the circle. What does that mean? The distance between the center of the circle and minus 4, minus 4 is greater than 5 units. That's what it essentially means. I said we're going to go with a counter example. The counter example, so this is what it said. The distance between the center of the circle and minus 4, minus 4 is greater than 5 units. This is a line that we know, which is x plus y minus 6 equals 0. Minus 4, minus 4 is a point here. They are saying this point, minus 4, minus 4, does not lie inside the circle. Let's pick the center of the circle. I'm going to pick a point. I'm going with the center of the circle to be a minus 10, minus 10. I love this number because it's a friendly number to work with. Let's first verify whether the distance between C and P is greater than 5 units. The distance between P and C is equal to square root of minus 4 minus of minus 10, which is a plus 6. 6 square is a 36 plus 36, which is root 72, which is greater than 5. So it's established that this distance is greater than 5 units. So point P, which is minus 4, minus 4, does not lie inside the circle if the center of the circle is at minus 10, minus 10. We have already computed the perpendicular distance between the line x plus y minus 6 equals 0 and the center of the circle, which is minus 10, minus 10, to be a value. We computed this value. That value from the last slide itself is 26 upon root 2. 26 upon root 2, we found it to be a value greater than 5. So if the center of the circle is at minus 10, minus 10, the perpendicular distance, which is the shortest distance between the line and the center, is greater than 5 units, which means that no point on the line is going to lie inside the circle or touch the circle. The answer to the question is no. This line does not intersect with the circle. This line does not touch the circle. Actually, we don't even have to go through all of these things and recollect things from the last statement. If minus 4, minus 4, which is the third quadrant point, is more than 5 units away from minus 10, minus 10, this line, which does not even come anywhere into the third quadrant, is going to be a distance which is going to be definitely greater than 5. So no was easy. Well, let's look for a point where it is going to be an yes, given the fact that the distance between minus 4, minus 4 and the center of the circle is going to be greater than 5 units. I'm going to pick again a very comfortable number for me. Let's check out whether it works. Let's assume the center of the circle to be at the origin. The center of the circle is at origin. Then the point P, whose coordinates are -4, -4. Let's check whether this perpendicular distance is greater than 5 units. PC, which is the distance between these 2 points, is equal to -4, -0, which is a -4 square, which is 16, plus another 16, y2 minus y1. This works out to root 32. Root 25 is a 5. Root 32 is going to be greater than 5. So this perpendicular distance, the distance, not perpendicular distance between C and P is a value greater than 5. The center of the circle being at 0, 0 is a valid circle to satisfy statement 2. Now let's compute the perpendicular distance. Perpendicular distance here is a very simple one. x1 is equal to 0, so ax1 is going to be 0. y1 is 0, so by1 is also 0. Minus 6 divided by square root of a square plus b square, which is 1 square plus 1 square. Modulus of minus 6 is a 6. 6 upon root 2 is what we'll have to find out. We actually determine that root 2's value is approximately 1.4. 7 upon 1.4 is equal to 5, which means 6 upon 1.4 is less than 5, which means that the perpendicular distance between the center of the circle, which is at 0, 0, and the line is a number which is less than 5, which means some point on the line is lying inside the circle. This line intersects the circle at 2 points. If the center is at 0, 0, it satisfies the information given in statement 2 and we get an answer which is yes. So sometimes no, if the center of the circle is at -10, -10. Sometimes yes, if the center of the circle is at 0, 0. So statement 2 is also not giving us a conclusive answer. 2 alone is not sufficient. Let's summarize it in a printed form. Again, I'm using the alternative approach here. I'm taking this point 3, 3 on the line. This will definitely lie on the line because it satisfies this equation. And I'm taking the center of the circle to be at 0, 0. The distance works out to root 18, which is less than 5 units, which means that if the center of the circle is at 0, 0, a point on the line is at a value which is less than the radius of the circle. We also computed that the 0, 0 to -4, -4, that distance is greater than 5. Therefore, -4, -4 will lie outside the circle. So center at 0, 0 and a point 3, 3. We didn't even compute the perpendicular distance. We found some point which is lying there, which is good enough. The answer is yes. Does this line intersect with the circle? Yes, it intersects. Now we're going to go to a different point. This point, the center of the circle is -10, -10. That and the point -4, -4, the distance we found it to be greater than 5 units. Root 72 is what we got. So this point definitely lies outside the circle. -10, -10 and this line, the shortest distance, which is the perpendicular distance, works out to a value which is greater than 5. The shortest distance itself is greater than 5. There is no point on this line which can lie inside the circle. The answer then would be a no. Got an yes sometimes, a no sometimes, which means statement 2 alone is not sufficient. We were down to B, C or E at the end of evaluating statement 1. Answer option B is eliminated. We are down to C or E. Let's combine the two statements and see whether it makes sense. Center of the circle lies in the third quadrant. Point -4, -4 does not lie inside the circle. Taking a counterexample approach, first case, I'm looking at the center of the circle to be at -10, -10. Satisfies the condition that it's a third quadrant point. We know that the distance between this point and the center of the circle is root 72, which essentially is greater than 5. So both statements are satisfied. The perpendicular distance between the point and the straight line works out to 26 upon root 2, which is a number which is greater than 5, which means that if the center of the circle is at -10, -10, the answer is a no. Now we need to pick one point for the center of the circle, which will satisfy both these things, and we get an yes. If that happens, then both these statements combined together are still not sufficient. Let me look at whether such a value exists. Let's go with a -0.1 and a -0.1. Does it lie in the third quadrant? Yes, both x and y coordinates are negative. Is the distance between these 2 points greater than 5 units? Let's verify that. Square root of 4 minus of -0.1, which is a 3.9. 3.9 square plus 3.9 square. 4 square plus 4 square is root 32. So 3.9 square plus 3.9 square is going to be a number which is definitely closer to root 32 and definitely greater than root 25. There's no doubt at all there, which means this is greater than 5. If -4, -4 and -0.1, -0.1, the distance between them is greater than 5, then this point lies outside the circle. So -0.1, -0.1 satisfies the information given in both the statements. Now all that we'll have to check out is essentially whether this distance, a perpendicular distance between this being the center and x plus y minus 6 equals 0 is a value less than 5. If I plug it in, that value, if you look at it, minus 0.1, minus 0.1, minus 6 divided by square root of 1 square plus 1 square would have been the perpendicular distance between the center of the circle and the line. That is minus 6.2, modulus makes it as 6.2 divided by root 2. Is this less than 5? 7 by root 2 is equal to 5 approximately, which means 6.2 by root 2 is a value less than 5. Then this line will intersect with the circle. We got an answer which is yes. At minus 10 comma minus 10 being the center, we got the answer as no. So getting sometimes yes, sometimes no, despite combining the two statements. So combining the statements together has not been sufficient. Choice E is the answer to this question. Before you leave, I want you to do two things. One, sign up as a trial user at wzko.in/core. The most comprehensive and affordable online GMAT quant course is available here. Try this course. You don't have to make any payment to try this course. Start with this topic, statistics and average. It will take you about 6 to 8 hours to get a handle on the topic. Take the quizzes, take the chapter tests, get an idea about how the teaching methodology works. If you find the teaching methodology helping you and meeting your learning requirements, pay and unlock the remaining topics. And lastly, before you leave, do two things. One, subscribe to this channel, youtube.com/Vizako, and importantly, turn on the notifications. So every time we upload a video or post anything in the community post, you get a notification for the same. Until next time, stay safe, stay healthy, and stay motivated.